The attributes that we've created so far are called instance attributes. They're tied to one particular object of the class. So for instance, my dog had a name, Fido, and its location was the kitchen. Underscore name is an instance attribute of pet dog, and in the case of my dog, it contains the object Fido. Location is an instance attribute, and in the case of my dog, it contains the kitchen. We could create another dog, as we did before. You'll remember Spot, and we'll just let Spot stay in the doghouse. So now we have two objects, my dog and your dog, and they each have their own instance attributes. They each have a different name, and they each have a different location. But sometimes we want attributes that are common to the whole class. For instance, we could create a class attribute called number of legs and define it to equal 4. So we're saying that pet dogs all have 4 legs. Not always true, but we'll go with that. And now we can say my dog is in its location and has this many legs. Let's run that. Fido is in the kitchen and has 4 legs. And we'll do the same for your dog. Spot is in the doghouse and has 4 legs. In fact, we can say dogs have 4 legs. Notice that I used the class name here, but I used an object name here. So we can access the class variable number of legs either using the class name or the object name. We can't do the same thing with object variables. If I try to access an object attribute using the class name, it doesn't work. We get this really strange result. In fact, this is the ID of the name function itself, rather than some instance attribute. So we can use class variables for a number of things. One thing is to keep track of how many objects of the class we've created. Like number of dogs. We'll start that out as 0, since at the beginning of our program we've created 0 dogs. Remember that the constructor gets run every time we create a new object. So let's take advantage of that and increment the number of dogs attribute each time the constructor is run. Remember, we increment by saying plus equals 1. Let's try this out. First, let's make sure we have 0 dogs in the beginning. We're going to say print there are. Notice at this point, I haven't created a single object of type pet dog, so I'm forced to use the pet dog class name to access the number of dogs. But if I run this, I see that there are 0 dogs so far. That makes sense. I haven't created a dog. But let's copy this code and add it again after we've created our first dog, my dog. Now the grammar isn't great, but after Fido is born, the class variable pet dog has been incremented, and now there's 1 dog. And after we create Spot, there are 2 dogs. So there's a difference between instance objects and class objects. We can change the location of Fido, and it doesn't affect Spot at all. But if we change the class object, number of dogs, it's felt by both Fido and Spot. We don't have to use the pet dog class here. We could use your dog, and we get the same answer. It's a class attribute. Its value is common to all objects of the class. Another reason we might want to use a class attribute is to create a sort of global value in the class, like max name length. We'll suppose that all dogs in our world have to have a maximum name length of 10, and we can protect that in the constructor. If the user tries to pass a longer name, we'll just assign it a default name. So if we try to call our dog Fido the king of all dogs, well, our first message was based on the parameter name, but we find out that Fido the king of all dogs is actually called Puff.